Hello, everybody. Welcome back to another workflow webinar series from Shure. As always, I'm Jason Waffle, joined with Miss Jen Liang Shabut and Mr. Ben Escobedo, the pro team from Shure. We are here on Fridays as usual at noon. Today we've got a fantastic panel. Before we jump into introing them, although you can see them on your screen currently, if you have any questions while we're running through this, please type them into the chat box in your control panel, get them over to us. We will do our best to get them answered. As always, you can sign up and see our pre-recorded and future webinars on shure.com/webinars. And email address to address us is proteam@shure.com, listed on this slide. So if we don't get to anything or you have something more pressing, fire us an email and we'll get back to you there as well. Without further ado, let's jump into introing these fantastic people we have joining us today. First off is the quite well-known Mr. James Stoffo, Principal and CTO of Radioactive Designs, RF extraordinaire, followed up only by Mr. Jason Glass as well, an RF guru in his own sorts, owner of Clean Audio Wireless. And lastly, we have Mr. Paul Klimson from Theory One Production. He's on tour with, he's normally on tour with Justin Timberlake and The Roots and a few other pretty fantastic acts. Guys, thank you guys so much for being here.
Thanks for having us.
Thanks for having us.
Yeah, absolutely.
Yeah.
All right, so without further ado, I think we'll just kick things off. Paul, why don't you start out and just tell us a little about who you are, where you come from, and maybe a little quick story of how you got into the industry, related to other guests or not.
Start off music and growing up all through high school and college, and got into audio really young, and that stuck. And started touring about when I was 19 out of Nashville. Did some time in St. Louis in the club scene before that. Nashville led to New York, and New York led to Broadway and broadcast and all the crazy things that happen up there. Spent some time at Mask Sound in New Jersey and learned a lot of gear. That Broadway world is pretty crazy on that side. And then after that, jumped back into touring, went through John Legend, Justin Timberlake, spent some time at Jimmy Fallon, NBC, did the late night and a part of this night show. And lately been out with John Legend, Alicia Keys, and Drake.
Nice, awesome. Mr. Glass, how about you?
Well, I started out as a lousy guitar player when I was a teenager with a high school rock band, and bought a PVXR 1200 powered mixer and a couple speakers on sticks when I think I still had my learner's permit to drive, so I think I was 15. And from there, I got my first pro audio gig when I was 19 in 1989 with a teeny little sound company in Detroit. A couple great guys there started teaching me everything. Got my first tour as a monitor engineer in 1990 with Tony Orlando and Dawn. And briefly went out as a system tech with a country act, Sawyer Brown, in I think it was 92. And the opening act on that was Mark Chestnut, and he hired me as a monitor engineer. And for the next 25 or so years after that, I was an artist monitor engineer touring. And during that process, of course, right at the beginning with Mark Chestnut, started using in-ear monitors, Garwood Futuresonics radio stations, and just immediately was really interested in radio frequency engineering. Started reading everything I could get my hands on, ham books and things of that nature. And by the time I was ready to retire from touring, I was with Dolly Parton, and touring acts don't get much better than that. So figured I'd retire on top and started my RF company, because by then I was regularly dealing with 60 RF channels a day on the road, and I actually would help friends out all the time with their RF at that point. So I decided to make it my profession, and in the interest of not traveling as much, which absolutely did not happen, because the money's out there somewhere, over the last few years, 4 or 5 years ago, I started working part-time on the side for the NFL as a game day frequency coordinator, and built up clients, a lot of broadcast, a lot of concert festivals, and that's what I was doing until we all stopped.
Awesome. Last but not least, Mr. Stoffo.
Yeah, so interesting. I didn't come up from the audio side or the music side. I started off as a radio surveillance technician in the submarine service for 6 years. So when we were at periscope depth, I was monitoring, I'm under this hat, what hair is left is gray. This was during the Cold War. I was monitoring Russian communications back then. And when I got out, I wanted a job as an electronics repair technician on radios, and ended up getting a job for a company called Vega Wireless, which was one of the big wireless mic and comp companies back then. And because my wife was in fashion, she told me to wear a suit to the interview. So instead of getting the job as the electronics technician, they made me sales and marketing manager. So next thing I knew, I was traveling around the Broadway into the Grammys and Paramount Studios and Disney World on behalf of this wireless mic and comp company. And so basically ever since then, my career has been pure luck. Just keep landing in the right place at the right time, and sort of took advantage of it. Next thing I mean, back then there was no such person as an RF tech. They didn't have RF guys on show because there wasn't, frankly, all that much RF other than Broadway and Disney World and broadcasters. And just kept falling into the right position and taking advantage of the opportunities that came up. Started Professional Wireless Systems in Orlando. Again, there weren't any real wireless companies, so when it came time to do RF for entertainment, I liked entertainment more than anything. So the entertainment parts of the Super Bowl and national anthem, the halftime show, just there was very few people to choose from back then. I guess that's the other good thing for me. So kind of slipped into it and just got all the big, huge gigs, and luckily didn't screw them up, so kept getting invited back. So that's where we're at. And the latest endeavor is just the wireless comm company, Radioactive Designs, because it seemed like a good idea at the time. So that's sort of where we're at now. Still doing shows, though. Not since February, but we will be again real soon. Looking forward to it.
Nice. That's some good career advice right there. Get lucky. Work a little hard. Awesome. All right, let's dive into some specifics of RF and nerd out a little bit. I know that's what a lot of people are here for and what I'm here for. So I guess just kick things off with what are your RF system design processes like, and what do you do to advance a show, and when you get there, and what are, I guess, the staples of a successful RF deployment, if you had to bullet point those a little bit. Anybody can fire away here on this one. Collaborate. It's a group project.
I'll start, actually. So, anybody who's got a business knows there's two rules, right? The rule number one is the customer is always right. Rule number two, if he's ever wrong, refer to rule number one. So when I'm setting up RF, you have a lot of masters. You may have the monitor tech, you have a front of house guy, you have to deal with mics, ears, communications. Now you're dealing with stage managers, director. So I find out what are the expectations from all of these various individuals, and it's usually 3 or 4 different masters you're serving. And so that, I think, is the ground zero. Where do you want these comms to work? Green rooms, the stage, backstage. Where do you want the mics to work? Again, green rooms sometimes, stage, obviously. And where do you want the ears to work? So I think that's the fundamental beginning of what establishes everything downstream from there is what are the expectations of each device. That's my intro. Now it's up to you guys.
There you go.
I'll hop in.
James, kind of the same thing, but more as a go-between. Figure out what an artist wants, where they want to go, obviously in the arena, but also, getting all the band numbers together, quantities, packs, mics, and then I refer back to whoever's the smartest in the room at whatever company stuff's coming from, and I will submit all the advanced stuff and say, here's what we're doing. And then you usually ask for a few extra parts and pieces if we're out for a long time, just to troubleshoot with.
Yeah, I'm along the same lines. Most of the time when I'm hired to be a system designer in tech, sometimes it's the audio designer of the show, especially if it's television. Sometimes it's the audio vendor's account rep who'll hire me, and then my next step after doing exactly what James and Paul do, is first I find out the overall objectives. fortunately, when you work with the guys that I work with, a lot of times you will have an idea from their budget already what specific pieces of gear they want, quantities and things like that. And I tend to then, I like to request scale drawings of the venue, the set. I want an overhead and an elevation at least. And I vastly prefer a CAD that I can manipulate in 3D, so I can get a feel for the ranges and distances we're working with, what obstructions might be in the way, which will change by the time we get there, but it gives you a good handle. And then
Yep.
I am OCD psychotic. I turn in an Excel sheet with manufacturer and model number down to the filter, down to the cable, down to the cable length. That's just my way of keeping things straight in my mind, and to make sure that the vendor provides those exact things so that when we get there, we're not trying to make something that's not ideal work. Even, you know, most of the time we can't get everything exactly what we want, but with RF being a science of trying to optimize everything that's within our control so that the things that are outside of our control don't cripple our system, it's really helpful to go into that with that attitude of I need to make this, everything that I can possibly control, be as close to ideal as I can. And then I use path loss calculators and tools like that in conjunction with knowing the antennas, their gains, their types, where they'll be located, how far from the talent they'll be. And so that's how we shape up the package. You know, it's a process.
Awesome. That's a good segue, I think, to dive a little bit deeper into the title of this webinar. It holds the word antennas in it. And I think if we could talk a little bit about what makes antenna selection and placement so important, and I guess some of your rules of thumbs on types and placement, and what you guys look for as you go into planning. You know, you mentioned you get CAD drawings, and I assume some of that is to kind of select what antennas and where you're going to place them. Is that correct?
Yeah, that's right. And I even try to go as far as, if it's a scale drawing, I can look at it, and in my mind, I can see, after all these years, the cardioid pattern of a LPDA, or I can see the hypercardioid pattern of a helical, or the circular pattern of an omni. And in my mind, that's what I'm thinking as I'm looking for places to position each of those antennas in that environment. And then I take the scale overhead drawing, and if it's got a scale on it, once I do my path loss calculations to my furthest talent position from the antenna, I get a measurement in feet from the calculator. I can then scale my pattern as an overlay on the drawing and scale it until it matches. Say the calculator says I've got 80 feet from this antenna to the talent, that gives me my 1000 microvolts at the receiver that I'm shooting for. I can place that overlay over the drawing, scale it to that 80 feet, and then move it around and manipulate it. And it gives me a really good idea of how it's going to behave when we get to the venue. And it's critical then to know your patterns, know your gains, because all those, you plug the gain into the calculator. It's a critical part of it.
Awesome. Klimson, Stoffo?
I can attest to his process.
Yeah?
I've heard his work, and it is black hole quiet when you put the ears in.
Nice. Okay.
So I'm not nearly that sophisticated. It's not that I wing it, but I think because I've used all these antennas for so many years, I have very simple choice. Of course, you could probably make most things work with just passive paddles, but very simply, if I'm dealing with in-ear monitors, which I almost always am, those get the CP dome antenna, which is Shure and PWS both have a circularly polarized antenna, unquestionably every time for ears. And for mics, I have 2 helicals. And the reason I use helicals on microphones and CPs on in-ears, they both have multiple polar pattern as far as polarization goes, which is what you're taking advantage of. Because an in-ear receiver, for example, it's on a person's body. It's very small, whip antenna, nothing fancy. So at the base station side, you have to make up for whatever you can to maximize your chance for success. Now, when the RF spins through space, as you can see there, it's literally spinning through space 600 million times per second. So even if there were a small multipath dropout on the in-ear monitor receiver, the electronics in the receiver is not quick enough to pick that up. And if it were, the human ear is not sophisticated enough to hear that dropout. So I'll always use circularly polarized for in-ears, and then helicals for microphones. And the reason that I wouldn't use helicals on ears is because whenever you have more gain in an antenna, you will always have a tighter polar pattern. So there is no way around that physics. The more gain you have, the smaller the beam width of the antenna. In other words, the more hyper you could call it if you're comparing it to a microphone. So since there's only one in-ear transmitter, that pattern has to be a little bit wider to cover a stage. But on the microphone side, they're diversity receivers, so you have two receiver antennas, and so thereby you can cover the entire stage with two more narrow beams, right, as opposed to one beam. I used to try to use helicals on ears, and the monitor mixer would always say, hey, I'm getting a dropout at several points on the stage, because the helicals transmit polar pattern. It's not just one strong one. It actually has lobes shooting off in directions, and there are nulls inside those. So we would get dropouts, and that's when I quit using helicals for ears. Always use CPs. If all you have is our log periodic dipoles or paddle shark fins, again, they'll probably work. But if you have access to helicals and CP domes, then domes for the base transmits and helicals for the base receive, mic receives.
A lot of the situations I get into are you just got the Jason glass and then the James Stoffo. Now there's the you walk in and see what's not there from your rider situations. And I did a lot of that system design during load-in on many gigs. Roots would usually do leave Friday night from New York City and fly to anywhere 8 hours away, string together 3 shows and fly back so that the crew could be in at 9:30 to sound check the guest band. So a lot of those, you walk into a festival and you get a varying degree of people who are now providing you gear and service. Their knowledge isn't as tight as having a dedicated RF technician who comes with the system. So you just start triaging and see what's there first, the condition of it. And then a lot of times on big festivals in Europe, the antennas will already be hung, and you look up, and if they're off the rail or in front of you and it's wrong, you'll have a transmit right next to a receive. So you just start at base 0, and as time and interpersonal communication permits, you negotiate to get things to serve your artist better for that day. And a lot of times we would kind of get lumped in as a headliner of taking care of the entire day's coordination on some festivals that didn't come with it. Any type of coordination.
Oh, joy.
So that happened to me all the time on the road, Paul, all the time, Dan.
Yep.
And I got to agree with James about circular polarization. I tend to select in any occasion where I require a directional antenna, I first go for a circular polarized helical variant. Because the dome antenna is also a variant of a helical. It's a shorter helix, so it has less forward gain. There's a couple of reasons for that. One is the circular polarization and polarization mismatch loss is minimized. It's always 3.1 dB. It doesn't change as the relationship between the two antennas changes. It's always 3.1 dB. That's one reason. The other is it's free gain without amplification. One of my design philosophies is to use only the amount of amplification necessary to do the job. And if I can get free gain without amplification, even if I don't need it, I can always attenuate later. and you suffer no penalty because, well, except for polar pattern, but that's something you're already thinking about anyway. So I'm of the same thinking as James.
And I got to add to that too, what you just said, Jason, extremely important. Signal to noise ratio drives everything. So by not having an active RF amplifier, like let's say even like the Shure inline mic receive amps, which I use, quite regularly for long cable runs. It's a 3 dB to 10 dB gain switch. Well, just think about this. A helical antenna is giving you 12 dBd without the amplifier noise. So if you can use an amplifier that gives you the same gain, or in this case, greater gain, than an active amplifier, if you use an antenna, like a helical antenna, that gives you enough gain equivalent to an active amp, achieve the gain, but you'll have a 10 to 12 dB better signal-to-noise ratio. And with analog systems, that will improve your audio quality and your range. And with digital systems, it will improve your range. So it's only a win-win situation if you could use a passive gain antenna, which, by the way, a shark fin is 6 dB of gain over dipole. A CP is about 6 dB, 3 to 6 over dipole, and a helical is 12 dB, 12 dB over dipole. Those are a couple of antennas that will give you better range, not just because of the gain of the antenna, but because of the signal-to-noise ratio that results from using passive gain as opposed to an active RF amp.
And you also eliminate, when you use a amplifier with wide open, no bandpass filtering in front of it, you open yourself up to the possibility of overload conditions in lots of different situations. When an out-of-band device like a two-way radio keys up too close to your antenna, it can put the whole spectrum into overload. And if you ever see a spectrum analyzer when an active stage is in overload, the whole spectrum goes crazy. And by not having filtering ahead of it, you open yourself up to that. And even if you do have filtering in front of it, if somebody walks too close to that antenna with a microphone and engages the RF limiters in the front end of your receiver, all the other channels that are past that limiter are having their signal to noise ratio squashed down by that limiter that's trying to handle the one hot mic that's too close. So you're by going all passive, you're eliminating that possibility of noise being generated by overload conditions.
And because for example, Axia Digital and the UHFR, which there are still plenty out there, I love them. I've been using them since they came out. Both of those devices squelch on signal to noise ratio. So you could have an absolutely RF signal. Both of your RF LEDs are pegged. And the audio will still drop out because the receiver says, oh, my signal to noise ratio is not good enough to pass this audio. It's happened to me, and that's when you, even on a digital, sounds great, and all of a sudden it's gone, and you go, wait, what happened? It was great, and my signal, my RF lights are pegged. Well, if you kill your transmitter and you look at the receiver with its own transmitter off, you'll probably see there are probably 3 or 4 lights lit. That's interference from something, and now you need to find out what that something is and kill it. But I've had that happen, and the AD is still fairly new. I mean, we're still learning about the field idiosyncrasies of the AD. Every new piece of equipment, it's going to be the best stuff on the market, but that's perfection yet. We still have to find out what is quirky about that system. And so you can imagine my surprise when I had a dropout on a Shure Axia Digital. I was like, what? This can't happen. And then sure enough, it was just, what had happened? Active RF amp in line to make up for some lost power because it was on a woman. It's always corporates, right, that challenges. LED wall, woman with the antenna right against her skin, in her bra strap, and so the body was shorting out 5% of the RF. So I had an inline amp, bingo, started getting dropouts, not because of a lack of signal, but because it raised the noise floor from the LED wall, and now your signal to noise told that receiver, squelch. So it's kind of almost counterintuitive. In that case, you want to reduce your gain to the receiver. You want to reduce your RF gain to lower the noise, giving yourself a better signal to noise ratio. So by adding 10 dB attenuation, you get more range. How's that for counter?
Less is more. Look at that.
And we should point out for listeners who aren't RF, technicians, we're talking about the receive side of everything right now. The transmit side's a whole different animal.
Absolutely.
And more power is not necessarily better in transmit, but it does have its occasions where it's not harmful. It's actually necessary. Okay.
Yeah, I think it begs the question right now, because we've talked so much about the receive side and your proponents for passive systems. Where would you suggest an active amplification process in your receive side? What merits that? When and where do you guys use that as a tool? It sounds like you start passively and use passive antennas in passive direction and line of sight to begin. So where do you run into a place where you're going to add active amplification, or do you at all?
Well, if you have to drive a couple 100 feet of cable, sometimes it's perfect,
Right.
without spending the extra money on fiber, which is the other alternative. And we tend to talk in worst case scenarios because we're trying to avoid trouble. But those Shure inline amplifiers, I own some as well, and I use them when I have to. They are extremely tolerant to the potential overload condition. They are very linear. They're excellent pieces of gear. It's just you have to be careful and really think about what you're doing when you use it.
So if you're using the Shure, the UA amplifier, they're inline, and I always get the inline ones. There are two rules definitely you want to follow. Is one, have a filter before that. So like if you're using, for example, now, say you have in-ear monitors from 470 to 530, okay? I would use a filter that goes from 550 to 650, right? And so you're sort of blocking out the power from your in-ears, again, lowering your noise floor from your own system, stepping on your own toes if you don't lower that noise floor. So when you use an inline amp, A, because of the long cable Jason mentioned, absolutely true. A, you want to filter it, and B, I don't put it right at the antenna because my antenna might be very close to the action on a stage. So you want to attenuate this signal a tad bit before you get to that end. So I'll put the filter at the antenna, then I'll run maybe 25 or 50 feet of cable just to kind of attenuate that RF signal a little bit, then my active inline amp, then the long run of 100 or 150 feet after that. That's how I set up RF amps.
Yeah, I was looking
That's
at
cool, James. I wouldn't have thought of that.
Yeah.
I'm going to do that now. Usually I stick them near the antenna. Cool.
Look at that. Mm-hmm. Everybody's learning today. What were you going to say, Paul?
Yeah, same thing when just having conversations over the years with people who've done it before you, and it takes a lot of discipline not to reach over and turn your Shure 1000 up to 100 if someone's having a problem. That's sure if you're in the middle of a show, maybe that's the fix of the moment, but if you have time and energy, it takes a bit to go, okay, let's leave it on 10 and figure out what the problem is downstream of that.
I've actually had occasions where it turned out that one of the problems with an in-ear system was multipath interference. And the user kept turning up the power till it was at 100. And the higher the power went, the worse it sounded. It got worse. And all we ended up having to do was move the antenna a couple feet left or right, which basically moved the multipath null to somewhere where the performer wasn't standing. It was completely, the power actually made it worse. And people, we tend to not think in those terms, especially us sound guys, who are used to carrying a Paragon or a Midas, where if you turn it up, it sounds better.
Mm-hmm.
Right.
No, so.
It is two different sides of the brain.
50
Absolutely.
milliwatts. 50 milliwatts generally is good. 50 milliwatts. If you're not making it happen with 50 milliwatts, I would look elsewhere before I would turn up the power. I would say, okay, where are my receiver antennas placed? Is there, invariably anybody who's a set designer uses as much metal as they possibly can on the set. For in-ears, I usually put my transmitter antennas under the stage, and that gets them within 10 or 15 feet from the artist, assuming the stage is not made out of metal. It's a nice, convenient place. Typically now with all the LED walls and flooring, that in-ear receiver is going to pick up that noise as well. And the only to fix that is to put the in-ear transmitter as close to the artist as possible, which generally means right under the stage or right off the stage left or stage right. And the beauty of the PSM 1000 in-ear receiver is it's got an adjustable linear RF amplifier. So as long as your in-ear transmitter signal is perceived as strong by the receiver, it will attenuate itself and give itself a better signal-to-noise ratio to improve your range and our audio quality as well, because it's an analog system.
And another approach you can take that, we have to have these multiple ways of looking at things. In converse to the way James is talking about doing it, where you go from under the stage, which works in many situations. When I'm designing a system where the antennas are far overhead, I'm looking at line of sight as not a infinitely thin line. I think about the Fresnel zone. So in my mind, I imagine a Zeppelin, a Hindenburg shape, scaled up or down based on the distance between that antenna and the performer, and try to envision all the different places in the performance space where the performer might go and avoid any obstructions within that Fresnel zone to each of those points, which is the opposite way of looking at it, where you're actually trying to not have any obstructions. And the difference is, in James's scenario, the philosophy is get the antenna as close to the performer as possible to increase signal to noise. Where that's not practical, you're increasing signal to noise by avoiding obstructions. Because the producers never want the antennas visible. So we approach that in all different ways to try to keep them out of sight, but still performing.
Awesome.
The one place where you can't get the antenna close to the artist is the receiver antennas, because if there's an LED wall, you've just put your receiver antenna closer to the LED wall. So that's another reason to use a high gain antenna. An LED wall in most man-made RF noise is near field. So if you can get your receiver, your mic receiver antenna 30 feet away from that, you'll be out of that near field noise, but you'll still have the gain from that antenna to pick up your artist's transmitter.
Nice. We got a couple questions from the field. I think Jen's gonna fire them out to you guys here. That's pretty relevant to the topic.
So a couple questions came in. The first one: would you use RF amps in the case of long-range transmission to get over the system signal floor where the receive RF input is quite low, even if all the cable loss is made up for?
No.
You're not supposed to do it, but I'm gonna go ahead and confess I've done it, and I keep it really low. Like, in other words, let's say you have a long run and you are just tapping one or two RF lights. I've been known to pop a Shure inline amp, I'm sorry, I confess, at the RF rack, but I'll only put it to 3 dB. If I need more than that, I'll move it up to the cable and make up for it. You can daisy chain those RF amps. Not recommended, but hey, if the option is no audio at all, so it's either take this risk, cross my fingers for the 3-hour show, or not get the show back because I'm fired because it doesn't work at all, I've been known to take risks, and that's one of them.
And I should confess, I design my systems. I don't design them with a 0 dB gain end to end. I do allow for around 3 or more dB of surplus gain at my outputs. The reason being is you never know. First of all, it gives you a little extra gain so you have room to attenuate. If you want to attenuate, say you've got an individual receiver in a distributed antenna system and an individual receiver is not behaving and it's acting like it's getting overloaded occasionally, you can put a little attenuation on just that one because you've got a little surplus gain to work with. And you never know when you're going to have to magically make another split to another receiver because of an oh, by the way. So I will confess that I do tend to design with a little bit of surplus gain to work with.
Cool. All right, other question that came in. Can you talk about the use of passive combiners in dealing with bias voltage through it and the termination of unused ports in the case of multi-zone receive antennas?
Jason, you go first.
Okay.
Jason definitely has thoughts. We can see it.
Most passive splitter combiners are of the Wilkinson divider type that do not pass DC. So if you need to pass DC, you would actually use a bias T on the antenna side of it to inject 12 volts on the line. When you're using passive combining, be aware of the isolation between ports. Most passive good quality Wilkinson dividers, you're going to want to see 25 or 30 dB of isolation between ports. And if you can, add isolators to get it better than that. And always terminate all ports unused, always. The reason being, signal reflects around inside systems, including that system that is your splitter or combiner. That little passive device is a system. At every port, signal reflects. If you terminate it with a proper matching impedance, instead of reflecting off of the port back inside, that signal, or in this case noise because it's undesired, is dissipated as heat in the resistor in the termination. If you don't terminate, that signal ends up back upstream somewhere, back in an amplifier where you don't want it, where it's going to intermodulate and generate noise. So best practice is to always, even if your system is, 801 combiners are extremely tolerant to not being terminated. Or 821 combiners are extremely tolerant to not being terminated. Most of the time, even with measurement instruments, you won't see any deleterious effect. It's still best practice to do it, because you never know. One time, you're going to get one that doesn't behave. You know, does everyone agree with that? I hope.
I have nothing to add. You covered that one adequately, for sure.
Perfect. Well, now that we sort of started to dive into multi-zone systems, I have seen all three of you work with that on a pretty regular basis. So when do you suggest using a multi-zone antenna system? Like
The Super Bowl.
I think when you, if they, again, you have to ask whoever your master for those devices are, but whenever you do an area that it requires coverage and you're not getting good coverage, in other words, your primary antenna system is so far away that it's not picking up this remote area, that's when you obviously start to think about a multi-zone system. The thing to remember is just the physics involved. There is no way around it. There will absolutely be a dropout somewhere between the two zones. There will be an RF phase cancellation. The trick is make sure that the RF phase cancellation happens in a bathroom or in a hallway or in a lobby that nobody expects coverage. But it will absolutely happen. And if we're talking microphones where you have diversity systems, I'll stagger my A-B antennas so that when the A side drops out, which it will somewhere between the 2 points, that the B side antenna processes audio from one or the other of the two multi-zones. And as you add zones, this becomes a little bit more complicated. But the idea is if you have a multi-zone antenna system and diversity from your mics, stagger those antennas throughout the zone so that only one side has a phase cancellation dropout at a time. Ultimately, it'd be great if while you're in one zone, you can't see that mic from the other zone. In other words, it's completely blind. That never happens almost. It's always more complicated than that. So at best, you can stagger your A-B antennas when you have to do multi-zone.
And keep in mind, when you do stagger your antennas, people, don't do it symmetrically. Use asymmetric spacings, because if everything's symmetrical, you'll get convergence of dropout areas. If you're asymmetrical in your spacings between A's and B's, your A and B are always going to drop out, theoretically, at different places in space, which is exactly what you want so you don't defeat the diversity. And if I might add, these days, I mean, am fortunate to work mostly bigger shows with decent budgets, but some of these multi-zone head ends that are out there from PWS and RF Venue and other third parties, they're so inexpensive for what they do that I pretty much always spec one as my head end, only for the reason that even if I'm only intending to do a single AB zone, I'm prepared. If for some reason we get to that venue and there's this one little area where they've decided a certain part of the show just has to happen, and my antennas have already flown out and I've got to get riggers back in the building to bring them in, to move them, it's real nice to have another couple of inputs that you can, all right, I'll throw a couple paddles over there, bingo, we're good. You know, some of these devices are only a few $100, you know, so even if you don't use it, it might be a good idea to have it in the rig just as a butt saver.
Here, out of curiosity, what is of all the big shows that you've done for any of you, what's the most number of zones you've had to deal with?
What was the walk like for the Timberlake Super Bowl? That was a long walk.
That was a long walk.
Inside, up the stands, down the stands, across the field, back to the centerpiece, up the other side of the stands. So we were way out of antenna range at any point from any one of the other points. And there was a brilliant system.
You were using Quadversity for that too,
Yes.
right?
It was one of the first times, correct? Is that the?
I believe that was the first use of Quadversity at the Super Bowl. And was Timberlake's performance. Yeah,
Super Bowl for sure. Yeah.
We weren't told. It was very hush hush what was going on, and until we walked the first time, and then everybody told us what was going on, and it was like, okay, that's cool.
And when I saw your specs on that, dude, when you did your presentation on it, my jaw dropped at what you guys pulled off. That was awesome.
Yeah, very awesome.
Yeah. Universal Studios week-long specials with Jimmy Fallon, 8 zones covering a good portion of the amusement park and linking everything to our soundstage. Was a lot of fiber, a lot of RF over fiber, a lot of zones.
Before that,
receive zones.
What led to that was Jimmy was used to in the building being able to travel anywhere on the 6th floor and 7th floor and loading dock and scene shop. Oh, let's go to the offices. Let's go in the elevator and do something there. And so once we got to Universal, it did turn into, oh, now we're across acres instead of just 2 floors in a building in Manhattan. But
they wanted to do a gag where they were going to have Jimmy and a guest ride in go-karts through the park and cover them with lavs.
Yep.
And it ended up getting, you know, we didn't do it, but we prepped for it and began to deploy. And that was a fun project because, you know, you're trying to make continuous coverage like you're talking about over a really large area, turning corners between metal buildings and down alleyways. It was pretty cool.
That sounds pretty awesome, actually.
Yeah.
All right, so let's pivot and talk about antenna cables a little bit. What are some of the misconceptions about lengths and gauge that you run into when dealing with antennas and the cabling?
Who wants it? Who wants this one? Did we lose James?
He turned his video off.
I think he just turned his video off. Jason, you want to start or either?
Yeah. I think there's some misconception about that the loss isn't the only thing that we should be considering. The reason some cables like Times Microwave LMR series or Belden 9913 F7, they're more desired and more expensive because they have 100% shielding. It's not about the power handling. It is about the loss, but it's also about preventing, especially with an in-ear monitor system, leakage between cables. When you have 24 mixes of IEM, say they're at 100 milliwatts, all crammed together into a rack with cables connecting each one of them to antenna combiners, any leakage which you would get from a 95% shield like RG58 is going to end up causing audible noise in your systems. Whistling, a faint whistling, that's a dead giveaway. I've been called to help clients out where we've got this whistling in all our mixes. Like, swap your cables out, use the expensive ones. And I should say that I recommend Shure branded jumpers because they're not actually RG58, even though they're spec'd as RG58. If you cut one open, they have a foil shield. So they're 100% shield. And that's pretty important. That's a misconception. I think people think that they can use standard RG58 and get the same performance when really you can't.
Hey, I'm back. I got grabbed by aliens.
Do you find shortest jumpers inside the rack helps as well?
No looping. No wrapping up loops and coils because you're creating a transformer.
Mm-hmm.
You do that, a choke coil.
Cool. We actually have 3 or 4 questions that came in about the under the stage antenna situation. I think a few of you, I think all of you have referenced that briefly. Do you want to talk a little bit more about like things to think about, how well it works, your experiences with that?
James, go for it.
Yeah, since I got data dumped here for a minute, but so the cool thing is with in-ears, they're FM receivers, frequency modulation, and so as an in-ear moves through different transmission zones, it will only lock on to one transmit antenna, even if it's the same signal going to 4 or 5 antennas. That FM in-ear monitor PSM 1000 receiver will only lock on to one antenna. And so if you have a big wide stage or a large area, you could actually split your in-ear monitors to multiple antennas. I've done as many as 16 actually. And as you walk from antenna zone to antenna zone to antenna zone, that it's called the FM capture effect. That FM in-ear monitor, the PSM 1000, will only stay locked onto one of those transmit antennas, the energy from one, I should say. And as you leave that one zone and walk into another zone, when the second zone becomes 6 dB greater than the zone that the in-ear receiver is locked onto, it will switch. And again, it switches in a microsecond. It's way too quick for the human ear to perceive or for the audio circuit in the receiver to process. So you don't know it. If you're carrying around a portable spectrum analyzer as you walk, you'll see the RF go down from one antenna, go up for the next one. You'll never hear anything in your ear. So when I have a wide stage, I'll put at least 2 or 3 antennas, stage left, center, and right, connected to the same source. It could be one ear, or it could be a combination, through an in-ear combiner, and it'll cover the entire stage because those are directional antennas. So yes, they're wider than a helical, but they might not cover a very wide stage. And yes, when you passively split, you're taking a power hit. If you split an in-ear monitor transmitter 4 ways, you're going to be down 369, 9 dB, right? So you're going to have, instead of 100 milliwatts, you might only have 25 milliwatts, but your transmitter is closer to the receiver, to the artist. So the inverse square law, you're making up for it. And in that case, it's not a phase cancellation because you're only transmitting one signal and your receiver's switching from one transmitter to the next, even though it's the same frequency. There is no phase cancellation on the transmit side, right? So anyway, that's just something to keep in mind, that you can split as many times as you want. If the stage has a lot of metallic content, it's not going to work. If it's just the structural supports and the stage itself is wood, then I can tell you for a fact it works just fine because I've done it hundreds of times.
James, haven't you found though? I mean, whenever I've tried that, every time I hear heterodyning whistling every time. So I tend to prefer switching. I keep a stock of multi-port RF switches, and I tend to lean towards the switching. Have you found? Is it more critical that you isolate each of those antenna patterns so that they're not as overlapping? Maybe take advantage of that attenuation of the stage between the antenna and the performer?
I have not had the whining and whistling happen, but typically they're Shure PSM 1000s, and I generally keep the signal to noise ratio very high because, again, the PSM receiver has its own automatic gain control on the RF side, so it's going to attenuate the noise to where it's inaudible.
I'm going to have to try it again.
Paul, did you use these on any under the stage things on Timberlake or any of your tours?
Yeah, we had a few challenges on Timberlake for antenna placement. It was in the round completely. There's the left picture is under the stage. The drummer is right above us. Lots of metal, lots of mechanics. There should be a picture of the outboard rack to the left of the console. If you want to go there next. You can see the my cue transmit was in my outboard rack because RF World had to be about 10 feet in front of me, downstage edge. There was no subs under the stage, which was great for, we shoved backline down there. Lots of kind of theatrical movements under the stage to load set pieces. We actually had Justin's MPC device on 2 Axient, the guitar packs. Is that the 81, I believe? And it was also battery operated, so a lift could come down. We could check it below the stage in solo mode, line of sight, because it was so close to the monitor board, was so close to the lift. And then it went up and it was completely movable anywhere on the stage. We also did Rhodes that way with a boat battery and a couple of 1/4-inch cables coming out of it. And it was great because when the Rhodes was plugged in, it hummed. And when he took it off the charger and battery power, DC battery power, the Rhodes didn't hum. So it was a lot of fun, creative ways, and we actually used the same frequencies for the MPC and the Rhodes because they played different times. So we saved a bit of real estate that way. We just adjusted the gain at the pack to make up for any audio leveling. But yeah, so the RF rack we used for Timberlake. Left-hand side IEMs, obviously. So we had 2 of the Shure, not the helical, but the bubbled ones on 50-foot poles behind the stage, and they tucked in real nicely between some screens. That'd be left on the picture, on both pictures, yeah. For the Q antenna, we were able to tuck something just up into a gap in the stage between 2 moving pieces. I had a tech on Q that roamed with a spare mic and also was my eyes. We had a switched Shure transmitter that he could use and give me cues straight to my IEM Q bus. So he could follow around, and he was essentially my eyes in the middle of the auditorium. On the other end, he could call in problems. He carried a couple backup IEMs, a couple backup transmitters. So anytime we could deploy stuff without me leaving the desk, which is crucial. But yeah.
Cool. All right, we're going to pivot a little bit. I think Ben's going to jump in here, and we're going to talk about the FCC that we all know and love.
Yay.
Yay. I mean, since this is our last webinar before Monday the 13th, which is the final date we've been talking about for several years now, I was wondering if you guys could maybe talk a little bit about the FCC Incentive Auction as we're approaching this deadline. How does it affect you, your customers, your inventory, et cetera?
We got a lot of spectrum gone. You got to know the rules now. You got to everybody check and make sure that any of your gear that's still capable of operating over 614 above it, look for firmware updates. A lot of the Shure gear, the other manufacturers, you have to update your firmware if it's available to lock out the illegal frequencies, or it's illegal to operate that piece of gear. Even if you operate it in a legally open space, if the gear's capable of transmitting outside of that space, no go. So, and James is really ahead on this.
I would really also recommend looking into getting your Part 74 license if you don't have one. You don't have to own any wireless microphones at all. I don't own any wireless mics anymore. I sold professional wireless 20 years ago, and I still have a Part 74 license because much of the spectrum that we have left is only available to people who have a Part 74 license. In fact, when we went to the FCC on behalf of the production community, when I say we, I mean anyone who's been to the FCC, and Shure brought us in. Mark Bruner from Shure is the one who invited me to my first meeting. We negotiated, or I should say we sort of begged, borrowed, and stole, but we did end up with some extras because they took away so much. What they gave us was they expanded a band that was reserved solely for broadcasters prior to this, and that's 941 meg to 960. That's a fairly new band. Shure makes, what is that your X band? Is that what your the number is?
X band, X55, yeah.
And you have to X55, and you have to have a Part 74 license to operate up there. Well, that's 20 megahertz that we don't have elsewhere now that was taken from us. We've lost over 200 megahertz of spectrum from everything from 616 to 806. We used to have all the way up to 806. We've lost that. And so what we got in return was a couple of little, crumbs here and there, but certainly 941 to 960 is a big one. In fact, on my last show, which was in February, that were all my primary RFs were Shure digitals in that 941 to 960 band, and you have to have a Part 74 license to use that space. So I have to make that recommendation.
And people, take a close look at ULXD VHF band. If ULXD produces an extremely high audio output, high quality audio output, and if it suits your needs, take a pretty close look at that VHF band. Get some of your stuff out of that UHF if you can.
I could tell you from firsthand experience of using VHF back again, first in the early and mid 80s, then it went away, and then with radioactive designs came back, and I could tell you there's nothing wrong with VHF. It works great. As a matter of fact, there are more VHF channels open in the United States right now than there are UHF. In fact, in most cities, VHF, you could find 2 or 3 open channels, which means as far as mics are concerned, you could put dozens of VHF mics in VHF.
But yeah, but I have seen somebody online mention mistakenly, it's not that TV stations are completely out of VHF. You still have to do your homework. You still have to, do what James and I and Paul always do is check the databases for active channels, scan, spectrum analyze if you can. So just be aware, the same best practices and diligence do apply. But as James says, there's a lot of spectrum available there in most cities. Even nearly impossible cities like LA. LA has one open VHF. That's 6 megahertz. That is extremely valuable if you got to do a gig there.
And that's the toughest city. Out of all of them, LA is the toughest for VHF anyway.
Yeah.
Does Shure on your website, don't you have a TV listing? If you punch in the city, you can find out the TV there? Yeah.
We do. Yeah, we have the frequency finder on the website, as well as the new wireless Workbench version has that baked right in. So if you're hooked up on the internet and you have Workbench open, you can just get real-time data about public safety and all the open TV stations and things of that nature. So it's a welcome addition. This is great info. We have a bunch of questions actually coming in from the field about this. One of them was, with the FCC selling more frequencies, do you think the future of RF will be crippled with increasing limitations, or will the industry be able to work around these changes? I think they're referring to, not only this auction with the 600 megahertz incentive auction, but maybe the impending T-band auction that may or may not happen. Maybe some thoughts on that.
Could I start that one, Jason, real quick? So,
sure.
So I think Monday, right? This Monday, the dust settles from the 600 meg auction, 700 meg auction that settled. I think that we're going to be okay. My feeling is that we're going to be okay for a number of years. But furthermore, it's very clear that as the FCC presents the concept of auctions, that manufacturers immediately respond, and before the auction is completed, manufacturers come out with a product that will solve the potential problem from the auction. So in other words, when I got into this business, again, I'm really old, right? So it's been like I started playing around with wireless in the early 80s. They only had one frequency. So if you needed 8 mics to work, you had to bring 20 because you couldn't change frequencies. So if you got interference, you had to turn off that mic and bring in another one. They were all crystal controlled, right? And then as we got more congested, multiple frequency wireless was invented. And now with all the spectral auctions, we have wider bandwidths. We have much easier to tune. We're moving into other spectrum. So in other words, manufacturers will respond. We have no choice. If we don't, we're out of business. So manufacturers will respond. And typically these auctions take so long to go from between the FCC's announcement and when the auction takes place. Like, look, I started going to the FCC hearing about these auctions in 2006. So it took 14 years from concept to, Monday when we're done. That gave manufacturers 14 years. A typical R&D cycle is 3 to 5 years. In other words, if you know in 5 years something's going to get your current equipment to stop working, you can generally come up with something new within 5 years. And the manufacturers have done so, and I'm confident that they will continue to do so.
And we can't forget the industries that have figured out ways to monetize spectrum, such as white space devices, have not gone away. And those moneyed interests are so wealthy and so well lobbied in Congress and to the FCC. It's my opinion. I receive a daily email blast from the FCC of all their official actions, and we still periodically see waivers being granted to different organizations that are steadily eroding the strictness of the technical specifications that white space devices have supposed to adhere to all along. And that is not going away. And those companies that have a financial interest in utilizing that spectrum will not stop because it's in their financial interest. They're not going to give up until that spectrum is ideal for their needs. And so we, as fellow users of the spectrum, of course, find ourselves at odds because we need it too. And we don't have that financial power or that lobbying power. So we have to stay diligent and not forget that that's not going away.
I just heard this morning, Boris, the UK Prime Minister, said he wants the UK to be full of broadband within the next couple of years. Well, broadband, that's white space. You look at Microsoft in the United States, the reason that their stock is doing so well is because of cloud-based technologies, broadband technology. Clearly, this is the future. There's no question about it. It's coming down the pike. And yes, manufacturers have to respond, and users have to be aware of all of this.
It's totally interesting because, I mean, when these white space devices were first announced, I remember back in like 2009 and so forth, they were talking about they would have to either determine if there was a wireless microphone operating and work around them. And then, that didn't quite work out. That didn't, wasn't applicable. And then after that, the white space devices, became like part of the database, and you have to register, and that was all part of the database. And as you guys know, the databases have kind of gone away with some exceptions, but now we're seeing more movement with the white space because of limited bandwidth. I'm curious, have you guys experienced white space kind of interference or how to work around that in your actions?
I actually have not identified a white space bogey in UHF that was obviously that type of data transmission. That's not to say that I maybe misinterpreted a source of interference, but I haven't seen anything out there in the wild. I believe I've heard of you, James, though. It had a couple hairy things happen, didn't you?
Did I freeze? Did I lose you guys?
There you go.
There you are.
James, didn't you have a couple hairy instances with white spaces in your world?
Well, yeah, but you know, Microsoft's my only corporate client, so most of it had to do with Microsoft R&D testing, and in the Seattle area, they're playing around with crosstown traffic. So I work with a couple of theaters in the Seattle area that were experiencing interference. We were able to get around it, and also in the Bay Area. So there are certain hotspots where we could look to that they're doing the testing first. Also, believe it or not, of all places, North Carolina had some incidents, but it's not by any means widespread, and there are no real, I mean, you could go on the internet and buy consumer white space devices now, but there's no infrastructure whatsoever. It's kind of like with the 600 meg auction with cell phones, okay? T-Mobile could go out and build as many towers in 600 meg as they want, but they're not doing any good until phones are available in 600 megahertz, right? So what we're seeing now is very sporadic, certainly not a large scale, and it's certainly geographically oriented to Seattle, the San Francisco area, and North Carolina.
That's great. A question came in kind of going back to like talking about link budget and losses and things of that nature. Somebody was asking if there is a piece of software or calculator that can be used to calculate RF gains and patterns when you're, like Jason, you were saying with your CAD drawings and that kind of stuff. How do you calculate your losses and link budget?
I can give you guys a link. I wrote a HTML RF path loss calculator that anyone can access for free on my website. When I have a second, I'll put it here on the chat. And that's for path losses from a source to a destination. As far as antenna patterns, you generally look up those patterns in your manufacturer specifications for the antenna. And then I keep a library of those graphics of those antenna patterns that I've manipulated in graphics software. And then that's what I use to overlay over my drawings and scale up and down for my general rule of thumb type calculations. But if you give me a second, I'll put that link up on the chat.
Cool. Thanks, Jason. How about you,
I have
Paul,
to find it.
or James?
You know, I actually like math, but I never use any formulas when I'm setting up. I'm that guy. I just eyeball it, you know, but I've been doing it for, 40 plus years, so you kind of get a feel for it. You know, I look for metal. I look for metallic content. I look for anything that might shadow. I think you guys had a graphic on your PowerPoint there that shows shadowing of RF. Generally, if there's not a ton of metal on a stage, I just sort of eyeball a stage. That's one of the things I do before I even think about where to set up my first antenna. Is I wait until most of the props are in and the stage is built, and I just walk around the stage and look for specifically metallic props and metallic objects.
Yeah, same here. Just eyeball, walk around, negotiate. You start seeing things differently, just from hindsight of what happened from the last time years ago, and just start placing antennas and seeing path length and routing. And that's a big one too, is I try to keep all antenna cable on top, mostly for fast loadout and kinkage. People will run over your stuff. You'll get lighting tossing their stuff on top of your antenna cables, and keeping it up. Do you ever find that tying off to scaffolding in festival situations changes things? Like if you tie your antenna cable up a pipe, is that something that's ever happened to anybody?
Not with good quality low loss. Although the
Yeah.
kinking thing, you got to be real careful how you tie it. You know, sometimes it's a good idea to take some of that foam tubing that you use to insulate pipes in your home and wrap that around a bundle. So because if you cinch it too tight and even crush it a little bit, it'll create a reflection point in your cable.
And that's a big one. I always try to communicate to my assistants that the antenna cable is our baby. It's our lifeline, because on a Timberlake, on a big arena tour, it's all ears. There's usually, in pop shows, there's no wedges anywhere. And I always try to like make the utmost apparency so that antenna cable is like eggs, and to treated as such.
I
Oh,
like
when you see a
loadouts.
stagehand yanking on it, oh boy, that makes your head explode.
I like the concept of short cable runs, primarily so that you get out quick on your loadout.
Awesome plan. I think in this one may apply to Paul, but all you guys can chime in. Somebody asked about now that we're primarily digital for the most part. Is there a different approach to filtering, specific to two-way radios and 600 megahertz fixed transmitters?
We were having issues with security radios under the deck quite a bit, and I think they did adjust the radios themselves. Something came back from production, and we had a different either radio itself or a modification to it.
I tend to do at least a wideband filter ahead of my first gain stages. And sometimes if I can do a strict enough band plan for the event, which isn't always, I'll go narrower. I'll do a set that's like 550 to 600, or I'll do different ranges. But that puts you in the position where you're locked in, where you can only tune to that range with your system. So when that's not possible, I'll at least do a 470 to 608 band pass to try to help with the two ways. Two ways generally live, if people don't know, between 450 and 470, which is just below our lowest range. And that's another reason I try to put in-ears down there. Well, one reason is everybody in the world is carrying G10 now for some reason. But you usually end up sticking your in-ears down there so that you don't have bleed from walkies blowing up your receiver antennas,
But as far as analog versus digital and filtering, I mean, RF is RF. If you need a filter, you're going to need a filter whether you're using an analog system or a digital system. The only difference is if you're going to have a dropout, with a digital system, you won't know it until it's too late. Whereas with analog, you could hear a little noise creeping up in there.
Absolutely, I agree. Having anybody key up a strong power source right next to your antenna can have detrimental effects, analog or digital. So filtering is filtering, right? A kind of a basic question came in about antenna connectors. So we have the N type and the BNC type, and you're familiar with both, obviously. Any difference between using them? Do you have a preference? Does it matter? Is there losses that you have to calculate with each?
So basically, the N connector is the granddaddy of them all, but almost nobody carries them. So if you really want to be that anal about every last quarter of a dB, which really in the long run probably doesn't matter that much, you're going to be terribly inconvenienced when you need to borrow a cable from somebody or if yours gets cut. I try to standardize to BNC because it's almost as good as an N, and everybody's got them. Most antennas have them, most cables have them, most head-end equipment, splitters, combiners. It's a 50 ohm connection, and they're easy to work with. So I would say, yes, there's a difference, but even on the biggest, most complicated shows, I haven't found it to be enough of a distance to justify the inconvenience of not having a BNC at your fingertips if you need it, if and when you need it.
Yeah, and that difference electrically is really, it's a curve. The difference between a BNC and an ends loss below 1 gigahertz is very, very close. As you go higher in frequency, the performance drops for a BNC, but maintains for the N. And I'm with James. I standardize all my stuff to BNC, but I still carry adapters and everything because I work oftentimes with Claire Brothers, and they're all type N. The other advantage to N, which some people see as a necessity for their application, is the physical strength of the connection. Of course, since it's threaded and it's a larger diameter and a thicker shell, it has its shear strength and pull strength are much greater than the BNC. But we shouldn't be treating our gear like that anyway. And the other advantage is the BNC is not a environmentally sealed connection. the end connector is environmentally sealed. So if you're installing an antenna permanently outdoors, then of course you're looking at an N. But most of the time, guys like us don't do that. We're in and out on a gig with our gear
as quickly as possible, you know.
Yeah.
And BNC, quarter turn.
That's right.
Yeah.
Another question came up regarding RF wargaming, and I think most of our listeners know about what RF wargames are. Basically, if you don't, basically you're trying to break the system and walk testing it, and worst case scenario, trying to make it fail so you know the weak points of your system. The question came up: do you always do the RF wargame method after doing frequency coordination? Is there any time that you wouldn't do it?
If you don't have a way to do an RF coordination, then the RF war game's all you got. But if you're going to coordinate and reprogram frequencies, it makes absolutely no sense to do the war game until after you've programmed. The RF war game really serves a couple of purposes. Yes, it'll find intermods that might exist in a combiner or an amp. But the other thing is it makes sure you didn't double program two transmitters on the same frequency. And usually when I have a bad hit on an RF war game, it's because human error, I program two things to the same frequency. But yes, you absolutely have to coordinate and program your gear first before you RF war game. The purpose of the RF war game is to make sure your frequency coordination is good.
That's a great point. I didn't think about that. The situation where you couldn't change the frequencies, that's all. The RF war game is all you got. That's awesome. Yeah, absolutely. And since we're like all nerding out here and we love gadgets and stuff, a question came up. What is the #1 gadget you always have with you related to RF and that you really can't live without? If you had only take one with you, what is it?
Spectrum analyzer.
Just
Spectrum analyzer.
Right there.
All right, spectrum analyzer. That's it. That's all you need.
Because as human beings, we can't see RF, and none of us can. And if anybody in the audience can, tell them to call me. They're hired. So you absolutely need a spectrum analyzer.
As a festival monitor engineer, I actually carried a whip for each frequency band because a lot of times Monitor World is in the back of the festival stage and the antennas are on stage and no one's made provisions for coverage where the monitor engineer stands. So I literally unplug the back of the queue and throw a whip on it.
Brilliant.
Saved my butt many times. That and a hardwired pack for queuing.
Yeah.
That's always in the work box in the Pelican.
Back when I was mixing Sarah Evans monitors, I built myself a little box where I could have the console hardwired direct through my box and flip a toggle and go to the PSM 1000 receiver just so I could compare. And if I had to run away from the console, I could throw that box off, plug in to Sarah and do my thing. But that let me listen to console cue because, the packs sound different than what's coming directly out of the console.
100%.
So, yeah,
and
hardware.
Different packs sound different because of the headphone amp in packs will be some older, some newer. Who knows if components are different on runs, but yeah, knowing what your artist is hearing is huge. Yeah, Compander. Yeah, knowing what your artist is hearing is huge. And obviously on the 1000s, you can go in engineer mode. And I actually had my pack had all 16 musicians and principal frequencies on it. And I would just kind of know where I was at by muscle memory and whose mix I was on. But yeah, it's huge to check to see that what you're sending is what they're receiving.
I had so many guys on stage on Hardwire's Upstage that it sounded different enough to me that I preferred to cue on Hardwire on their mixes. We had on Dolly, we had this bass player. He was the quietest listener, and he had a Hardwire. And if I plugged into his pack, I'd have to turn it up. It's the first time in my career, and he could hear everything, like a gnat whizzing by. It was insane. So I had to listen on a Hardwire for him. I mean, he could hear things in the noise floor. It was crazy.
I think I know who you're talking about.
And he was never wrong either. That's the thing. Like he's a good engineer.
Yeah,
which was awesome.
I think it was the same person. He was having me change ratios on drum compressors on that gig.
Since we're talking about antennas, and we were throwing out some earlier, we were talking about some cables and things of that nature. We're just curious about some of your favorite RF cables, like stuff that your go-to that you would like to see all the time if you can get it. What brands and models do you guys like?
For in-rack jumpers, I like Times Microwave LMR 195 or 240. And then for long runs, I like Belden 9913 F7. It's the most inexpensive equivalent of that type of cable that I'm aware of. It's not as tough as some others. Professional Wireless and Claire are using, what is that stuff, guys? Airwave?
Yeah,
EchoFlex?
it's a poly.
EchoFlex?
Yeah,
It's got a little bit more of a harder outside, right? The F in the 9913 stands for flexible, so you can coil it up a little bit easier, right?
Yeah, the stuff PWS sells is also air dielectric, so it's got a center conductor, and instead of a foam or some other dielectric between the center conductor and the shield, it's just this plastic that's being held in, sort of like a shock mount on a studio microphone, and so it's air dielectric now, pretty much, and it's very low loss. It's about 2 dB per 100 feet, and it's really flexible. So I try to get my hands on that whenever I can.
You got to test it every time, though, because when they get old, and you got to handle it carefully. Airspace, just by its nature, needs special care. So people need to know that. Yeah,
that brings us
great
to
stuff, though.
To our next question. What tools are you using to test your cables, ports, and losses?
I don't run a single cable unless I check it with a spectrum analyzer and a tracking generator. You can't just use a DC voltmeter because it might have great continuity, but certain frequencies there's a dip in because it's got a kink, or as Jason said, the air foam dielectric smashed, so it'll still show good DC. After I test the cable and know that it's good, I put some white tape on either end, gaff tape, and label it, IEM or RXA or B. But if it doesn't have the tape, it doesn't go out.
There's also a handy gadget out there. It's a USB device made by a company called AIM, what are they called? The device is an AIM UHF, if you look it up. And mine might be obsolete. I think there's a new version of it, but it's a one-port device. So most of us test with a signal generator. James mentioned a tracking generator that's connected to your spectrum analyzer data port and synchronized. And you put your device under test, being your cable, between the signal generator and the spectrum analyzer. You generate a signal, the spectrum analyzer reads the signal and shows you what you need to know about the cable. Nice thing about single port devices is they base all their measurements off a pulsive signal that sends down the cable, and it measures the reflections. And some advantage to that, not so much with cables. It tells you the same information about a cable as the other setup does, but it could tell you a lot of information about the load at the other end of the cable, meaning the antenna. And you can actually use these, it's called a vector network analyzer, is what it's called in the RF world. And you could characterize and tune your antennas with it. So that's a handy tool to have, and those can be had. There's some cheap USB models out there under $500 that I haven't personally used, but I've seen others recommend them. And the one I use is just under $1,000, and I love the thing for that. So that's an alternative for folks who don't want to go the whole spectrum analyzer route.
I will say I just saw that RF Explorer, which is a pretty low cost spectrum analyzer. It's sort of, I would say, an entry-level spectrum analyzer. They sell a unit now that has a tracking generator built in, which I think is pretty cool. It's it does the job. You're not going to tune a receiver with it or anything, but you certainly could use it to shoot cable, and I think it's in the $400 region, maybe a little less. Yeah. So look it up, RF Explorer. I don't get a commission. I'm just putting that out there.
Well, and I should plug on James's behalf, the RAD TX8 antenna combiners have a go, no go test LED on their outputs, which is really nice. man. It's green. If it's green, it's go. If it's red, it's no go. You know you got a problem with either your cable or your antenna.
Yeah, that's built on VisWAR, voltage standing wave ratio. It just sends a, it's measuring the return, the reflection. Jason talked about the time domain reflectometer, or that vector analysis. Well, all we're doing is looking for a return from our signal. You've heard of 1 to 1 VisWAR, 1 to 2 VisWAR. If it's 1 to 3 or greater, you get a red light. If it's within 1 to 1 or 1 to 2, it's green. And if it's between 1 to 2 and 1 to 3, it's yellow. So it's not going to smoke the combiner, but it'll just let you know, hey, I don't have 50 ohms here. Maybe you split, like we just talked about. You took your in-ear monitors and you split to multiple antennas under the stage. Well, you no longer have 50 ohms at that point, because you've now, paralleled out multiple antennas. So you probably have 25 ohms or less if it's more than 2 antennas. So you'll get a red light, maybe a yellow light. Not going to smoke the combiner, but it just lets you know you have a bad VisWAR, a bad reflection coming in.
And people, don't use Y adapters, please. Use a proper Wilkinson divider and get your impedance match. That's just my humble opinion. I'm sure James will agree.
Yeah, I agree on that. And also, Mini Circuits has a lot of great components, very inexpensive, $38 for filters, $38, $40 for splitters. Just know that those cannot take a ton of power. Don't use those to split multiple transmitters, and they also are a DC short. So if you plug it into a Shure wireless mic splitter, you're going to shut the splitter down. I'm telling you, I know from experience is how I found that one out.
Nice.
It won't smoke the Shure splitter, but it'll shut it down. And then when you go, oh my God, and you disconnect everything, it'll turn back on, and you go, okay, good. And just don't do that again.
I always preferred when stuff would smoke, because then I could smell the problem.
Let the magic smoke
silicone.
out.
Hey. Awesome. Thanks, Ben and Jen, for jumping in on some of those questions. We are pushing here on our 90 minutes, so I'm going to toss out one final question for you guys to ask. It's a bit of a softball one, and that is, what is your favorite piece of Shure gear that you've used or use frequently? Round robin here. You don't like it at all?
I'll start. Axie and Digital.
Mm-hmm.
Oh, wow.
Axie and Digital is my favorite. Yeah.
Awesome. Paul,
Go ahead,
Glass?
Paul.
Obviously, for monitors, it's Shure 1000s. I mean, coming up through the years from 600s to 700s to 900s, and you match a good Shure with a good sealed mold ear, and you can do anything.
Nice.
I'm not joking when I say this, guys. A hardwired SM58.
Hard to beat that.
It is.
If you're an audio guy, your heart, if that's where your heart is. I said in another webcast somewhere that I consider the SM58 to be one of the most perfect machines ever made by humankind.
Wow. We might have to quote that.
Yeah.
I think we're going to pull that out. Awesome.
Yeah.
Well, gentlemen, this has been a fantastic 90 minutes. I know myself and many of our viewers have learned quite a bit. So thank you, Paul, Jason Glass, and James Stoffo, for being here. You guys were fantastic. We appreciate you taking your time out of your Friday to be here, although I'm not sure how busy all of us are at the moment. Hopefully that changes here shortly. Bit of housekeeping before we say goodbye. As always, the first and third Tuesday of the month, everybody, we have our Pro Tech Talk. That is basically where our Shure internal Pro team gets together and just answers your questions. Anything you've got from a question standpoint in the field, anything we didn't get to today, anything that pops into your head during the week or from some gig you were doing when you were gigging, and bring those questions to us. You can register there at the website listed in front of you. We will continue our Friday workflow series throughout this month. Next week, we're going to talk about making the switch analog to digital. That is both analog to digital wireless, as well as kind of an overall analog to digital workflow. So we'll talk a little bit of Dante, a little bit of fiber, a little bit of Axion digital, the whole gamut. The week after that, on the 24th of this month, we are going to talk broadcast monitor mixing. Got a pretty all-star panel from some of the Grammys mixers for their monitor path coming through. And we're still working out what we're going to do at the end of this month. So if you have suggestions, let us know. With that, one more big thank you to Paul, Jason, and James, and everybody that's running the background here from Shure. Thank you guys for being here, guests. We appreciate you showing up, and we'll see you guys a week from today. Thanks, everybody. Have a good weekend.
Thank you, everybody.